Hello, I hope I'm audible. Sorry for the inconvenience. The previous video stopped recording in the middle. So this is a new recording. The previous video with the questions will also be uploaded along with this video in YouTube. So no worries. So I have already dictated all the questions with respect to this live session, seventh live session of the course Soil Mechanics Geotechnical Engineering 1, the topic of which is Shear Strength Chapter 2. Right now, I'll start with the solutions part. Just a moment. Yes, I'll start with the solution part right now. Okay, the first question was a cylindrical sample of soil having cohesion of 0.8 kg per centimeter square and friction angle of 20 degree is subjected to a cell pressure of 1 kg per centimeter square. Calculate the maximum deviator stress at which the sample will fail and the angle made by the failure plane with the axis of the sample. So in this case, start the solution. In this case, yes, we know that sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. Okay. Now sigma 3 is given. What is sigma 3? What is sigma 3? Sigma 3 is 1 kg per centimeter square. Okay. Phi is given 20 degree. So alpha is the angle made by the failure plane with the axis of the sample. No, that we have to find out. Alpha is the angle made by the failure plane with the plane of the major principal stress. Yes, sorry. So this is the angle made by the failure plane with the major principal plane of the major principal stress or the major principal plane. The formula is 45 plus phi by 2. So here the angle alpha, that is the failure angle, we obtain as 55 degree, and we have the value of cohesion given as, yes, 0.8 kg per centimeter square. Okay, 0.8 kg per centimeter square. So now putting everything in this equation, sigma 1 equal to sigma 3, that is 1 tan square alpha 55, is alpha equals to 55 plus 2c tan alpha, c is 0.8, 2 into 0.3 into 10, 55 degree. We get the value of sigma 1, as approximately equal to 4.32 kg per centimeter square. Okay. Now the deviator stress, the maximum deviator stress, the stress as the sample will fail. That means the sample will fail. So deviator stress, that means the total axial stress minus the confining pressure. That is sigma 3. So sigma 3 is 1, sigma 1 is 4.32, subtract that, we get 3.32 kg per centimeter square. Okay, the first part, the maximum deviated stress, has been completed. Next, angle made by the failure plane with the axis of the sample. Now, if this is the sample, this is the major principal stress. So, this is the plane of major principal stress. If the sample fails like this angle is alpha, angle made by the failure plane with the plane of the major principal stress. Now, we are asked to find out the angle made by the failure plane with the axis of the sample. The axis of the sample is this one, the vertical axis. So, we have to find this. Suppose this is theta. Suppose this is theta. Okay. So, theta, angle made by the failure plane with the axis of the sample, will be what? Will be simply 90 minus alpha. 90 degree minus alpha. Simple. So, alpha is 55 degree. So, theta will be how much? Theta will be 90 minus 55, that is 35 degree. So, the angle made by the failure plane with the axis of the sample is 35 degree. Okay. I hope the solution was clear. I'll go to the next question. Yes. An embankment 5-meter high is made up of soil whose effective stress parameters are C dash equals to 50 kN per meter square. Sorry. And phi dash equals to 16 degrees and gamma equals to 16.2 kg per meter cube. The pore pressure parameters as found from triaxial test are A equal to 0.4 and B equal to 0.92. Find the shear strength of the soil at the base of the embankment just after the soil has been raised from 5 meter to 8 meter. Assume that the dissipation of pore pressure during the stage of construction is negligible. Yes. And that the lateral pressure at any point is half of the vertical pressure. Yes. So in this case, we are told to find out the change in the shear strength, that is when the embankment has been raised from 5 to 8. So for that we need to find, for shear strength we need to find out the effective shear stress, and for effective shear stress we need to find out the existing shear stress along with the increment in the shear stress, and for that we have to find out the normal stress. We have been given the normal stress over here. For that we have to find out the effective normal stress, for which the total normal stress along with the change in the normal stress. Okay. So first we have found out the change in the normal stress, that is del sigma 1. Due to this increment in the height, it is generally gamma into del h, that is 16.2 into, what is the difference? Difference is 5, 8 and 5, 3. That is equals to 48.6 kN per meter square. Okay. Now it has been said that lateral pressure at any point is half of the vertical pressure. Okay. So what is del sigma 3? What is the change in sigma 3? It is half of the change in sigma 1. That is equals to 24.3 kilonewton per meter square. Okay. Now the change in pore pressure can be found out from the Skempton's pore pressure parameters. Del U, the formula is parameter B into del sigma 3 plus A del sigma 1 minus del sigma 3. Okay. So putting all the values, I think yes, that will be here. Putting all the values, we get approximately del U equals to 31.3 kilonewton per meter square. Okay. Now to find out the effective stress after the construction has happened, what was the original, normal stress? Sigma 1. What was sigma 1? Sigma 1 will be equal to gamma into H0 original. What is H0? H0 is 5. H0. So 16.2 into 5. How much? 81. 81 kilonewton per meter square. Okay. So now the effective stress, that is sigma 1 dash, because for finding out the shear strength we have effective stress parameters C dash and phi dash. Okay. So we need to find out sigma dash. Okay. Sigma 1 dash will be also called as sigma dash, which is equals to sigma 1 plus change in the normal stress del sigma 1 minus del U, that is the pore pressure. Sigma 1 plus del sigma 1 minus del U, that is the pore pressure. So 81 plus 48.6 minus 31.3, we get approximately, 98.3 kilonewton per meter square. Okay. Now shear strength. We were told to find out the shear strength. What is the shear strength? Now shear strength. What did we have to do? We only had to find out the effective normal stress. Everything is given. C dash is given. C plus sigma dash and phi dash. Now phi dash equals to how much? Phi dash equals to 16 degree. C dash equals to 50 and sigma dash equals to 98.3. Putting all the values in the respective places, we get a value of around 78.2 kilonewton per meter square. Okay. So first we found out the change in the effect, normal stress, then change in the minor principal stress, and then using the pore pressure parameters we found out the change in the pore pressure. Next we found out the initial normal stress, from which we then calculated the effective normal stress after construction, initial plus change minus pore pressure, and then tau equal to C plus sigma tan phi. Putting all the effective parameters in equation, we get the value of shear strength as 78.2. 78.2. Okay. I hope it was clear. I'll go to the next question. A standard specimen of positionless sand was tested. Okay, fragile compression 482, cell pressure was 100, effective shearing resistance of sand, Devator stress, major principal stress, testing the cell pressure of 200. Okay, this is an easy question. So we have the value of sigma d given and sigma 3 given. Here, cohesionless, that is C equal to 0, C equal to 0, sigma d, Devator stress equals to 482, and adding the units, and sigma 3 equals to 100, equals to 100. Now sigma 1 equals to, we know, sigma 3 confining pressure plus deviatory stress sigma d, that will be equals to how much? 480 plus 100, 582 kilonewton per meter square. That is the value of sigma 1. That is the value of sigma 1. Now we know that equation from triaxial test, sigma 1 equals to sigma 3 tan square alpha plus 2c tan alpha c equal to 0. So from here we can write, we have these two thing only, from which we can write tan alpha equals to root over of, you see, sigma 1 divided by sigma 3. Okay, from which we get alpha approximately equal to 67.485, and then again using alpha equals to 45 plus 5 by 2, we get phi equals to approximately equals to 44.97 degree. 44.97 degree. I'll just write it. Phi equals to 44.97 degree. Okay. Now for the next specimen, when sigma 3 is 200, when sigma 3 is 200, then sigma 1, now again it is sand, for the second specimen is also sand, so C equals to 0, same case, the correlation will be 0, so sigma 1 will be equals to how much? Sigma 1 equals to sigma 3 tan square alpha. Now we have for the same specimen alpha equals to 45 plus 5 by 2 equals to 67.485, as we have found out. Sigma 3 is 200. So we get a value approximately, yes, 1164 kilonewton per meter square, sigma 1. So effective angle of shear and resistance, it is phi equals to 44.97 degree. For the next case, the major principal stress we have found out 1164. Now the deviator stress, we know sigma d is the deviator stress equals to sigma 1 minus sigma 3. So 1164 minus 200, it is 964 kilonewton per meter square. Okay. This is the deviatoric stress. I hope it was clear. Next question. Yes. A consolidated undrained test sigma 3, sigma 250, 275. Yes. So sigma 3 and sigma d is given. So sigma 1, again sigma 1 equals to sigma 3 plus sigma d at failure. 250 to 75, it is 525. 525 kilonewton per meter square. Okay, this is the value of sigma 1. Now, for undrained test, here is a catch. We have asked for undrained triaxial test for normally consolidated clay. For normally consolidated clay. Generally, clay they have cohesion, but when you are talking about normally consolidated clay, and in the case of undrained triaxial test, the cohesion value will be considered as 0. It is negligible and considered as 0 in this case. Okay. So the equation becomes sigma 1 equals to sigma 3 tan square alpha. Sigma 3 tan square alpha. Again, from here, tan alpha equals to root over of sigma 1 by sigma 3, from which alpha we get approximately 55.4, and using alpha equals to 45 plus pi by 2, 45 degree plus pi by 2, we get phi equals to approximately 20.8 degree. Okay, this is the value of phi. So we have got the angle of friction. Now the angle between the failure plane with the major principal plane, that is the alpha. Alpha also we have got 85.4. So part A and part B are over. Now finding out the normal stress and shear stress on the failure plane. So for that we know normal stress sigma on the failure plane goes by the equation sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos 2 alpha, cos of 2 alpha. This equation, putting all the values alpha, sigma 1 and sigma 3, we get a value of approximately 338.67 kilonewton per meter square. Okay. Similarly, for the shear stress on the failure plane, tau equals to the formula sigma 1 minus sigma 3, this is minus sigma 3 by 2 sine 2 alpha, sine 2 alpha. That gives us a value approximately 128.54 kilonewton per meter square. Okay. The part C, normal stress sigma equals to 338.67 and tau shear stress equals to 128.54 using the given equations. Okay. I hope it was clear. Next question. Yes. A particular soil failed under a major principal stress of 300 kilonewton per meter square with a corresponding minor principal stress of 100. Same soil, minor stress is 200. Yes. So, for the first case, okay, the general equation we'll write down over here. Sigma 1 equals to sigma 3 tan square alpha plus 2c tan alpha. Okay. Now for the part A, we have phi equals to 30 degree, right? So alpha will be how much? 45 plus pi by 2, 15, will be equal to 60 degree. Now putting all the values in the equation, we have now sigma 1. Okay, sigma 1 is 300, measured, yes. Sigma 3 is how much? Sigma 3 is 100. Alpha we have got. Now from here, find out the value of C. What is the value of C? The equation becomes 300 equals to 100 tan square alpha, alpha being 60 degree, plus 2C tan alpha. From this equation, we can get the value of C as 0. Why? Because tan square alpha is 3. 3 into 100, 300. We don't need this second part. Okay. So C equal to 0. So now, since the soil was not given, we have to calculate and find out that the value of C is 0. So now this equation becomes, if C is 0, sigma 1 equal to sigma 3 tan square alpha. Okay. Now when phi equal to 0, okay, before that, sigma 3 tan square alpha, before that, if the minor is 200, yes, if the minor is 200, then sigma 1 becomes 200 tan square alpha. Tan square alpha is 3. It gives us value of 600. Yes, the second part was to find out the value of major when the minor is 200. For the next case, that is for the part B, phi equal to 0 degree, phi equal to 0, from which alpha you can find out using the same equation, alpha equals to 45 degree. Okay, so from here and the first equation, sigma 1 equals to 300, 300 equals to 100 tan square alpha plus 2c tan alpha. So tan alpha equals to 1, you get a value of C as 100 kilonewton per meter square. Okay. Now, if C is equals to 100, again, sigma 1 for the next case, for the second case, minor principal, sigma 3, 200 tan square alpha plus 2C tan alpha, alpha is 45, C is equals to 100. Okay. So this is 1, this is 1, 200 plus 40, this becomes 400. Yes, 400 kilonewton per meter square. Okay. So analytically, we are finding out the value of cohesion being not given here because we don't know the type of soil or the cohesion value. So analytically, we are finding out the value of cohesion from the major equation and the first condition is given. And with that, in the second condition, we are finding out the major principal stress. Okay. Next question. Yes. In an unconfined compression test, a sample of clay 100 mm long and 50 mm in diameter fails under a load of 150 Newton at 10% strain. Calculate the shearing resistance taking into account the effect of change in cross-sectional sample. Now, 10% strain. What is 10% strain? That means 10 by 100, that means 0.1. So strain, that is axial strain, equals to del L by L equals to this epsilon equal to 0.1. Okay. Now, the initial diameter A0 is equals to pi by 4 into d square. Is d? D is 50 mm, 50 square. We can solve this or not solve this, but we'll be needing this now where when we are talking about the area of cross section at failure. What is the value? Initial cross section area A0 divided by 1 minus del L by L. That is epsilon. Okay. So using this, we find out the cross sectional area at failure approximately equal to 2181.7 mm square. Okay. So if this was the cross section area at failure, now for finding out the shearing resistance over here, there is a shear strength. Okay, it is unconfined compression test. I have said in the last class that in unconfined compression test, the shear strength is half of the compressive strength. Okay, I will show the graph again over here. This is tau and this is sigma. The Mohr circle goes like this. So this is the value of Q. There is the normal stress at failure. This is the UCS or the compressive strength, and this is the radius. This is the maximum shear strength, or this is the shear strength of the soil. So this is half, and since it is performed on clay, saturated clays, so phi equal to 0, so tau f equal to Cu, undrained cohesion. Okay, this is the shear resistance. So for that, first of all, you have to find out the compressive strength, okay, or the compressive stress at failure. What will it be? It will be the load at failure, if the load is Pf, divided by the area at failure, Af. What is the load at failure? Pf equals to 150 Newton divided by 2181.7. Now, upon solving this and converting this into Kn per meter square, we get a value of approximately 68.75 Kn per meter square. Kn per meter square. Okay. Now, shearing resistance is the shear strength, that is, you can write as tau f or equal to Cu equals to Qu by 2. Now Qu equals 68.5 divided by 2, we get approximately 34.38 Kn per meter square. Okay, 34.38. Clear? Now, next question. I hope this was clear. Next question. Yes, so formation of cohesion-rich soil, 3 meter, depth 50% saturation, average body ratio 0.5, specific gravity 2.7, friction angle is 30 degree, depth of 2.5 meter. Okay. So here we have the values, void ratio we have E 0.5, saturation, degree saturation is the S, value of S, G, we have G, depth of 3 meter, depth of 2.5 meters. So this is the H, this is the value of the water table depth. Now, first of all, to find out the normal stress, we have to find out the unit weight first of all. Okay. Now for the first case, the water table is at 3 meter depth. We are told to find out, this is the water table. We are told to find out the shear strength at a depth of 2.5 meters. So this soil is dry. So for that, we will find out gamma initially, G plus SE gamma W divided by 1 plus E. We get the value of gamma. Okay. E we have, wide ratio we have, G plus SE, S we have, gamma W is 9.81 kilonewton per meter cube. Okay. So from here, the value of gamma we get 19.29 approximately kilonewton per meter cube. Okay. Now the value of sigma at 2.5. This sigma is sigma effective because there is no water up till 2.5 depth. That will be equal to gamma H. H is 2.5. We get the value of sigma as approximately 48.23 Newton per meter square. Now finding the shear strength, tau. C plus sigma tan phi. C is 0 because it is cohesionless soil. C equal to 0. So it will be C plus sigma tan phi. This is 0. Sigma we have got, sigma dash, and tan phi. Sorry, not alpha, it is phi. Sigma tan phi. This is 0. Phi is how much? Phi is 30-degree friction angle given over here. So putting all the values, we get approximately 27.85 kilonewton per meter square. Okay, kilonewton per meter square. Now in the next case, modified value of shear strength, the water table rises up to the ground surface. Okay. The next case, gamma sat we need to find out because this whole thing is underwater. Okay. This whole thing is underwater. So now gamma sat will be equals to how much? Gamma sat will be equals to G plus AC. S will be equals to 1. So I'll just do it once. 2.7 plus E 0.5 into 9.81 divided by 1 plus E 1.5. Yes, 20.928. Simple, in this case S equals to 1. It will be approximately 20.928. 20.928, and gamma submerged will be how much? Gamma sat minus gamma W. Gamma sat minus gamma W, it will be equals to 11.118 with the units obviously. Sigma at dash at 2.5 will be using this gamma submerged into H, that will be equals to 27.795. Now tau F, tau equals to C is 0, sigma tan phi, sigma dash tan phi will be equals to how much? Approximately 16.05. 16.05 kN per meter square. Okay, a bit tedious, but I hope you understood. Next question. Two samples of a soil tested in a triaxial testing machine all round. Okay, so in this question, the first is 2, 7.7, 5, 13.7. So now, in the first test, sigma 3 equals to 2, sigma 1 additional axial stress. So adding both, we'll get sigma 1 equals to 9.7. In the second case, sigma 3 equals to 5, sigma 1 equals to how much? 5 plus 13, it will be 18.7. Okay, 18.7. Now we have sigma 1 and sigma 3, and we have this equation sigma 1 equals to sigma 3 tan square alpha plus 2c tan alpha. Okay, so using both the values of sigma 1 and sigma 3, we get two equations. So two equations, two unknowns, we solve them simultaneously, and then we get a value of tan alpha and c. Okay, tan alpha and c. So here the equation will be solving simultaneously for two equations, two unknowns, from which the value of c will be getting approximately as 1.068 kg per cm square, and the value of alpha, from which we will get phi. The alternate value of phi will be equals to 30 degree. We will get alpha equals to 45 plus phi by 2. From here we will get the value of phi. First we get the value of alpha, then the value of phi. Okay. So the main equation again, sigma 1 equals to sigma 3 tan square alpha plus 2c tan alpha. We have two values, sigma 1 and sigma 3. Put them in the equations, we get two equations with two unknowns, solve them to get the value of c and phi. Okay. Next question. Cohesive soil with a shearing resistance of 15 degree and a cohesion of 35 kilonewton per meter square. Specimen is subjected to triaxial compression test when the value of lateral pressure in the cell for failure to occur at a total stress of 300. Okay. So firstly, the equation again will write sigma 1. This is the main equation, is the most important equation. As you can see, each and every sum almost are using these equations, plus 2c tan alpha. Okay, 2c tan alpha. So now in the first case, phi is 15, this is phi, and cohesion is 35. Okay, from phi we can find out alpha. Okay, alpha same formula, alpha will be 52.5 approximately. Okay, 52.5. Now using these values as alpha and c, what shall we get in this equation? Total stress of 300, that is sigma 1 equals to 300, equals to sigma 3, okay, tan square 52.5 plus 2 into 35 tan 52.5. Okay, now just rearrange this equation and you will get the value of sigma 3. We have to find out the value of lateral pressure in the cell for a failure to occur, total stress of 300. So sigma 3, the value of sigma 3 will get as approximately 122.96 kilonewton per meter square. Okay, simple sum. Next question. I'll just finish these questions now. These are simple sums. Okay. How many questions are left? I think five, six questions are left. Yes. Okay. Unconfined compression test is conducted on a cylinder of soil, fails under axial stress of 1.2. Failure plane 50 degree. So again here alpha equals to 45 plus pi by 2, 45 plus pi by 2, from which phi value will get alpha is 50 degree, 50 degree, get phi equals to 10 degree. Okay. So we get the angle of friction over here. Now it has been said unconfined compression test. So sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. Sigma 3 is 0. So from here c equals to sigma 1, c equals to sigma 1 by 2 tan alpha. Okay. Sigma 1 is how much? 1.2. Okay. So from here the value of c we can get as, and alpha is 50 degree, we can get as approximately 0.5, 0.503 kg per cm square, because the axial stress is also in kg per cm square, so it will be also in kg per cm square. It will be 503. Okay. Next question. Consolidated drained test, it has been said, specimen clay fails at 60 degree, 60 kilonewton per meter square. Effective shear strength parameters are C, and C is 15, phi is 20 degree. Okay. Again the same thing, phi is given, so find out the value of alpha. Alpha equals to 45 plus pi by 2. Here it has to find out the compressive strength. So this is a bit tricky. So phi is 20 degree given. So alpha will be equals to 55 degree. Okay. 45 plus pi by 2. Now we have sigma 3 as 60. This is sigma 3. So sigma 1 equals to sigma 3 tan square alpha plus 2c tan alpha. Alpha equals to 55, c equals to 15, and sigma 3 equals to 60. Okay, from here we can get the value of sigma 1 approximately 165.24 kilonewton per meter square. Okay, Newton per meter square. This is the value of sigma 1. Now, what is compressive strength? Compressive strength over here, it means the maximum vertical compressive stress. Okay, maximum vertical compressive stress. That is how much? That is the deviatory stress. That is the deviatory stress, because we are asking to find out only the axial one and not the lateral one. Okay, only the axial one. So sigma d is the deviatory stress, the axial stress only, and is equals to sigma 1 minus sigma 3, the compressive strength. Whenever we are talking about compressive strength, we know that is a parameter found out in the uniaxial testing. So when we are considering about the uniaxial testing, we should always remove the confining pressure. Okay. So 165.24 minus 60 gives us a value of approximately 105.24 kilonewton per meter square. Okay, sigma D. This is the compressive strength. Clear? Next question. Saturated clay effective stress parameters of 10 and 28 degree. No dissolution of pore water. Sigma 1 60, sigma 3 10, and UF equals to 120. So now value of sigma 1 and sigma 3 at failure. Very simple. For the first part A, sigma 1 equals to sigma 1 effective plus U, there is a pore pressure, that is 60 plus 20 equals to 80 kilopascal. And again sigma 3 equals to sigma 3 dash plus U, that is equals to how much? 10 plus 20, 30 kilopascal. Okay, so part A has been solved. It's like that. Now in part B, we have effective normal stress on the failure plane. Effective normal stress on the failure plane. Now for the failure plane, phi is given. Find the value of alpha, 45 plus pi by 2. Okay, 59 degree. Effective normal stress on the failure plane. So effective normal stress means sigma dash equals to, we'll use the effective parameters, sigma 1 dash plus sigma 3 dash divided by 2 plus sigma 1 dash minus sigma 3 dash divided by 2 cos 2 alpha. Okay, so sigma 1 dash 60, sigma 3 dash is 10, alpha is 59 degree. Put in the values, we get a value of approximately 23.26 kilopascal. 23.26 kilopascal. Okay. Now the value of undrained shear strength. Value of undrained shear strength. Now here, whenever we ask to find out the undrained shear strength, okay, and then we ask to find out this for a sample of clay. For a sample of clay. Here it is not said that this sample of clay has been naturally consolidated. Okay, naturally consolidated. So in this case, for the value of undrained shear strength parameters, we will take into consideration that the value of phi u or phi undrained equal to 0 for undrained shear strength. So that the tau value equals to Cu, undrained cohesion. Again, we can find out sigma 1 equals to sigma 3 tan square alpha, sigma 3 tan square alpha plus 2c tan alpha. Okay, 2c tan alpha. Now sigma 3 is 30, sigma 1 is 80. Okay, and then in this case alpha equals to 45 plus pi by 2. Okay, alpha equals to 45 plus pi by 2. If pi equal to 0, the value of alpha will be equals to how much? 45 is equal to 45. 45 plus pi by 2, pi is 0, it will be 45. So put the values, we get the value of C u, which is the also equals to tau. Okay, approximately 25 kilonewton per meter square or kilopascal, whatever. Okay, the main thing takeaway from this sum is for undrained shear strength, the value of phi u, that is the undrained friction, is 0, from which the value of alpha becomes 45 degree. 45 plus pi by 2, pi equal to 0, alpha is 45 degree. Now this same equation we have tau equal to Cu because pi equal to 0, and hence using the equation sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha, we can find the value of C, which is equal to Cu, undrained cohesion, which is equal to tau, that is the undrained shear strength. Here the value is 25 kilonewton per meter square of kilopascal. Okay. Next question. Yes, identical soil sample. This is almost similar to the one sum debate of stress we have been given. So first one, for the first specimen, sigma 3 equals to, we have cell pressure 200, and sigma 1 we have debate of stress plus cell pressure. It will be how much? It will be 970. For the second part, we have sigma 3 equals to 400 and sigma 1 equals to 400 plus 1370, that is 1770. Okay. Again, from the equation, sigma 1 equals to sigma 3 tan square alpha plus 2c tan alpha. We put the two values of sigma 3 and sigma 1 in this equation, two equations, two unknowns. We find the value of c and phi. The value of c we obtain as, from this equation, solving the simultaneous linear equation, we obtain as 42.5 kilonewton per meter square, and the value of phi from alpha equals to 45 plus pi by 2, phi equals to approximately 36.87 kilonewton per meter square. Okay. Now in the second part, same soil tested in direct shear apparatus with a normal stress of 600 kilonewton per meter square. Now tau equals to c plus sigma tan phi. Okay. Phi 36.87, c equals to 42.5, and sigma equals to 600 with the value of phi, value of tau. Okay. Shear stress at failure equal to shear strength approximately 492.50 kilonewton per meter square. Okay. So same thing, two cases, two scenarios, two equations, two unknowns, c and phi. Find the value of c and phi. Put the same in the direct shear equation. Tau equal to c plus sigma tan phi. Sigma is 600. Find the value of tau. Shear stress at failure. Okay. Next question. Okay. In this question, the normal stress is given 295. Okay. And the water pressure is given. So the effective stress we can find out. Effective stress equals to total stress minus the water pressure. Okay, total stress minus the water pressure, 295 minus how much? 120. It will be 175. 175 kilopascal. 175 kilopascal. Okay. Now we have sigma dash given. Now shear strength parameters, we have c dash and phi dash. So tau effective shear strength equal to c dash plus sigma dash tan phi dash. Put the values in this equation. C dash equal to 12, sigma dash 175, tan phi dash is 30. We get a value 113.04. 113.04. Okay, so this part is important, finding out the effective stress from the total stress. Okay. Last question. Consolidated undrained test. Okay. First of all, saturated sand has been set over here, for which C will be equal to 0. So we remove one parameter initially. Now we have cell pressure 100 and debate of stress of 350. So what is sigma 1? That is the major principal stress. Sigma 3 plus sigma d, 350 plus 100, 450 kilopascal. 450 kilopascal. Okay. Next, to find out, we have to find out the total and effective shear strength parameters. Now in the shear strength parameters, we have two values, namely cohesion and angle of internal friction. For a saturated sand, the cohesion equal to 0. So we have to find out the two values, effective angle of friction and total angle of friction. Okay. So here we find out first sigma 1 dash, sigma 1 minus u. Now u is already negative, so it will increase because of suction. It will be 450 plus 40, that is 490. And sigma 3 dash, sigma 3 minus u. U is already negative, so it will be 100 plus 40, 140. Now we shall use two equations. The first one, for the total stress parameter, sine phi equals to sigma 1 minus sigma 3 divided by sigma 1 plus sigma 3. Sigma 1 is this, sigma 3 is equals to 100. So sigma 1 450 minus 100 divided by 450 plus 100, from which the value of phi, total shear strength parameter for angle of friction, approximately equal to 39.52 degree. Okay, 39.52 degree. Now for the effective stress parameters, here we will write the same equation, sine phi dash effective angle of friction equals to sigma 1 dash minus sigma 3 dash divided by sigma 1 dash plus sigma 3 dash. Because effective friction we are finding over here, so we'll use effective sigma 1 and effective sigma 3. From here, effective sigma 1 is 490, effective sigma 3 is 140. So 490 minus 140 divided by 490 plus 140. Solving this, we get the value of phi effective equals to approximately 33.75 degree. 33.75 degree. Okay. This was the last term. I hope the solutions were clear. Those who are joined, thank you for joining the class. We'll again meet in the upcoming session. Thank you.